All right, so here's what we're doing today. Like I said, we are going to talk about what are called permutations today. And we're going to get into things that are just permutations. Tomorrow we'll talk about combinations. It's the idea of how many different arrangements could things come up with. Since we're looking at patterns, we're going to look at arrangements and things along those lines. So if you take a look at the first example here, this is going to get the idea. You're going to recognize some things in this lesson today. Okay? In how many different ways could we arrange three distinguishable objects in order, with order being taken into consideration? First question. Why do I have the word, what does distinguishable mean? Why is that in there? Yeah, they're not the same. They're not two of the three objects are not the same. All three of the objects, whatever you're talking about, are three different things. And then the other part is we have to take into consideration that we're going to arrange those where the order matters. Okay? So for example, what I'm going to do is I'm just going to say, let's call it object A, B, and C. Okay? And so if you take a look at objects A, B, and C in this case, I'm going to start off doing it this way. First option, or first object, could have either A, B, or C, could come first. Okay? So I'm going to put it together if you've done any probability in the past, if you remember. I'm going to just show you as like a tree diagram, if you will. Okay? So option number one, you could have A, B, or C could come first, whatever the three objects are. It doesn't, the objects don't matter, it's just the order of them. Assuming that the first object was A, what options do I have for the second object? B or C. So object number two could be B or C. If the first object is B, second one then, the options, could be A or C. And if first one is C, last one is either, or second one has to either be A or B. Okay. Now if we finish this off, we've got kind of the first two options, and then we'll put it all together. If the first object is an A, the second one is B, what's the only one left? C. There's one combination. A comes first, then object B, then object C. That's one permutation. Okay? That's one option. You could have object A, then object C, then object B. That is, now notice, and here's when I talk about where the order, why I underlined order. Okay? ABC and ACB, even though it's the same stuff, they're in different orders, so they're two different permutations, is what that's called. Okay? There's two different ways to arrange it. If we go down to the bottom part here, and we kind of just finish this off fairly quickly. If I go B and then A, only thing left is object C. B then C, the only thing left is object A. C then A, only thing left is B. And finally, there's the last one. How many total ways could we arrange those three objects? Okay, so it's kind of a long, fairly drawn out way to go through and do this. You end up with 6 different ways. So if I said A, B, and C, there's 6 different ways you could arrange. I'm just going to use the letters, A, B, and C, okay, where the order matters. Yeah. That's where we're headed. So let me show you a different option, a different way of thinking about this. This is what is called, if you're in stats, I'm assuming you've talked about the multiplication principle of counting, okay? You may not recognize it in terms of the name, but I'm sure you've used it before. Think about it this way. If I've got the 3 objects and I need to arrange them, I'm going to put kind of blank number 1 here. How many options do I have for the first spot? 3, right? How many options do I now have left to go in the second spot? 2. And how many options for the third spot? 1. And if I take 3 times 2 times 1, you get the same exact answer. You get the 6 different ways we were talking about, which is also what Sadie had just talked about, and Sadie just said, isn't 3 times 2 times 1 just 3 factorial? Here comes the factorials back as well. But now you'll have a little bit more understanding of where a factorial can be used actually, okay, when you're trying to solve different problems. So there's kind of the setup of things. There's the idea of what's going on. Let's take a look at the next one. Next example using this idea of different combinations, different permutations. So if we're talking about license plates, and we want to figure out, this is the old version, okay, of what license plates used to look like in Wisconsin. They had 3 letters followed by 3 numbers. What is it now?
4.
Yeah, there's 4 numbers. We'll talk about that in a little bit. So if we go the older way, and I'm trying to figure out how many different arrangements could I have, how many different license plates could we come up with, based on the fact that you have 3 letters and 3 numbers. And for part A, we'll say there's no restrictions. What I mean by that is you could have A, and A again. You could have 1, 1, and 1. Okay? You can have duplicates if you want. There's no restrictions at all. So if we think about this idea, I'm going to think about it in terms of blanks. Okay? First option, how many, if we're starting with letters, how many options do I have for the first letter? 26. Times, how many options for the second letter? Still 26, because there's no restrictions. I can have repeats. I could have A again if I wanted to. So I still have 26 options. How many for the third letter? Still 26, because there's no restrictions. Then we move to the numbers. How many options for the first number? 10, because you could have 0 through 9. There are 10 options that could go in that first spot. You could have a 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. So there are 10 options. And then 10 again, and 10 again. Get an answer for me if you would. Type that into your calculator. Tell me what you get. What's the total number of, if there's no restrictions, and this is how our license plate are arranged, how many total possibilities do we have? It's a big number.
1757600.
You have 17,576,000 different combinations of license plate you could come up with. Okay. Which turns out, by the way, one of the reasons why they added a number wasn't enough. Let me ask you this. So now, if I added one more number, what would this final answer be? Times 10. You'd go from having 17 million possibilities to 170 million possibilities just by adding an extra number to the license plate. They went from 17 million to 170 million. And now you got plenty of options. Now you don't have to worry about that's why they did it. Okay? And then that's not even including the customized ones or any of those kind of things that you could have. Let's say if we added in part B here. What if I added some restrictions? Saying that no letter or number could be repeated. Okay? So you can't have any repeated letters. You can't have any repeated numbers. In that case, how many options for the first letter? 26. 26 letters in the alphabet. How many options for the second letter?
25.
Now, because you can't have any repeats, there's only 25 options for letter number 2. And how about the third letter? 24. Okay? Then we switch over to numbers. How many numbers? 10. And then we would have 9 numbers left to choose from and 8 numbers left. If you type that in, what do we get?
11,232,000.
And so another thing I want you to take a look at is, part of the reason I left the answer up from the first part is if you notice, if all we said was one restriction that you just can't have any repeats, that eliminated about 6 million different options because you can't have a repeat letter or a repeat number. So again, just taking a look at kind of some number patterns and options and all those kind of things. Okay? Let's go one step forward here. What we are talking about is what is called a permutation. Okay? When the order matters, we're talking about what are called permutations. Okay? And once again, a permutation very simply is the number of ways that a set of, when I say n objects, whatever we're talking about, could be arranged in the key part where order matters. Okay? Where ABC is different than ACB. Okay? Those are two different things, even though they have the same letters. Where we're headed tomorrow, by the way, just to kind of connect it already, tomorrow when we talk about what are called combinations, we're going to be looking at ABC and ACB, same thing because they have the same letters. Even though they're in different order, we're going to ignore it. We don't care about the order tomorrow. That's the main difference between today and tomorrow. Okay? If you take a look then, I also put on in your notes, we talked about this. There are n factorial permutations when I say in an n set, when I'm talking about the number of objects. Like on the first problem, we said we had 3 different objects. It ended up being 3 factorial. If I said, let's take 10 letters, and how many different ways could you arrange 10 letters? 10 factorial. 10 options for the first spot, 9 options for the second spot, and all the way down, okay? So that's where, again, where the factorial is coming into play here a little bit. Okay. Any questions so far? Doing okay? All right, let's keep going. So now if we take a look, now I want to figure out if I have the word dragonfly, okay, this 9-letter, and notice I put in quotes, I put words. I'm not really talking about words, I'm talking about really just arrangement of these letters, okay? So count the number of different 9-letter words that can be formed using the letters in each word. So if we take a look, first question, do I have any repeats? No, okay? So that makes it a little bit simpler. I don't have to worry about any repeated letters here. How am I going to find this answer? What am I going to do? 9? 9, 8, yep, you got 9 different letters that you can choose from for the first spot. 8 for the second spot, 7, so it's really just 9 factorial. Which, if you remember on your calculator, if you don't want to type in 9 times 8 times 7 times 6, remember, hit the math button on the calculator, and then arrow over to the probability menu at the top. I believe it's all the way to the right. And the fourth one down is your factorial button. In this case, if you took the letters from dragonfly and you rearranged them, you would have a total of 362,880 different ways you could arrange those letters and come up with different arrangements. Like I said, I put words in the directions, but really it's just arrangements of letters. All right. Let's take a look at this one. How is part B different than part A? There's a repeat. So we got to consider because if all I did, if I took the word butterfly and just switched the 2 letters, the 2 T's, is that different? Or do we end up with the same word? It's the same word. So we got to eliminate all the times where if all you did was switch the 2 T's, the fact that you get the same end result. So we're still going to start with the 9 factorial. Okay? We're still going to start with 9 factorial. But now I have to eliminate all those times where I could just switch the T's. So therefore, we divide out. In this case, since there's 2 letters that repeat, divide out 2 factorial. Okay. Which in this case, 2 factorial is just 2. 2 times 1. So your answer is going to be half of what you came up with in part A. You end up with 181,440 is what you should get. Okay. So we have to divide out, like I said, anytime we just switch the 2 letters, you still end up with the same result. Okay. How about part C? If you notice, when we're repeating, you got 3 B's and 3 E's. Where am I going to start this problem? 9 factorial. Starting with 9 letters. Okay? 9 factorial. We are going to divide out. Now, let me see what you think. What am I going to divide by? 3 and 3?
It's probably that, yeah.
Let me ask you this, because these are really, I'm guessing it's one of the 2 thoughts in your head. Is it 3 factorial and 3 factorial? Okay? Because you got 3 B's and 3 E's. Or is it 6 factorial? And what I want you to think about, are those answers the same? Do these equal each other? No. These do not equal each other. And like Addie just said, it's exactly what the reasoning why. We're not looking at 6 letters that are 6 of the same letters. So it's not 6 factorial. We're looking at 3 B's and 3 E's. So we have 3 factorial and 3 factorial. Okay. 3 factorial for one of the letters and another 3 factorial for the other letters. If you type this in, here's what you should get. I want you to type it in and see if you get it.
Oh, that's what I got. You can't change the 3 factorials to 6.
No, because it's not the same. 6 factorial is 6 times 5 times 4 times 3.
Like just 6. Like 3 factorial is 6.
I mean, you could change you could change it to 6 times 6, yeah.
Right.
Yeah, you could do that.
And then 9 factorial.
Except 6 times 6 is 36.
Oh.
But you could do that, yes. You could do that. Quick question, if you didn't get the answer, anybody tell me why?
Dead or wrong.
If you type it into the calculator just like I have it written on the board, and that's why I gave you the answer. I wanted to see if you'd make the mistake of just typing it in exactly. The calculator is programmed to follow order of operations. If you type it in like this, what the calculator is going to do is take 9 factorial divided by 3 factorial, get an answer, and then multiply that answer by 3 factorial. It's going to do the order of operations. That's not what you want. You want it divided by this entire quantity. So if you have something like that, make sure you put the parentheses. Make sure you tell the calculator, divide by this whole thing. Okay? That's what you got to make sure you tell the calculator. Any questions so far? You guys doing okay with permutations, factorials? All right, let's move on to kind of the definition here, and then we'll wrap things up. Hey, do me a favor too. There's a lot of people that are like half paying attention. Let's go a little more full paying attention. Okay, let's go back to number 1. Let's be present, please. You're going to have time to work, so let's be present during the lesson so you understand what's going on. Permutation counting formula. Everything we've been talking about today has been what are called permutations, like we already said. Well, here's your permutation counting formula. Like I said, this is kind of a setup for what's coming in the tomorrow and then into next week. So the number of permutations, the number of different arrangements of n objects, taken r at a time. Okay, I'll talk about what that means in a second. Here's the notation. Okay, n permutations of r, npr. N factorial divided by n minus r factorial. Okay, the difference of the two. Here's what this means according to how I've been teaching this. R, as we take a look, that is, let me put this up above here. If we're talking about number of blanks, that's what R is representing. Like we had said before when we were talking about the license plates, we had 3 letters, 3 numbers, and we had blanks basically of, all right, how many options for the first spot? How many options for the second spot? That's what R is representing, the number of spots you're trying to fill in. N represents the number of objects that you're filling them in with. So when we did the license plate, you had the first spot, you had 26 options. That's the 26 was the N. When we said no repeats, then the second blank was 25 options. That's what when I say number of objects, that's what I'm referring to. Okay? So with that being said, anybody tell me why this must be true then? If R is greater than N, why do you end up with 0 arrangements, 0 permutations? If you think about what N and R represent, it should make some sense. Anybody tell me why? Yeah. Think about it. That's exactly what it is. You got more spots than objects to fill them with. Okay? If you had, let's say, 10 blanks, but you only got 5 objects, there's no way to fill 10 blanks with 5 things. That's what that says. That's what's going on here. If R is greater than N, your answer is 0. There are no ways to come up with that. Okay? You got to be able to fill all the blanks. You got to be able to fill all of the spots. Okay? So this is what a permutation is. It's kind of the definition of it. Let's do what we did. Let's do the math a little bit. We're going to do it by hand, and then I'm going to show you on the calculator too. So in this case, if we use the formula we just came up with, and I'm trying to find how many different arrangements are there if you've got 6 permutations of 4. Okay? I'm going to use the factorial, and then we'll also talk about the blanks idea. So according to our definition, the top number was, let me go back to it just so you see it, n factorial. Okay, that's the first number. So in this problem, we have 6 factorial on top. The bottom is n minus r factorial, the difference between the two. So in this case, we would have 2 factorial on the bottom. And now you could go ahead and you could type that in. Again, I'm going to do it by hand because I want you to understand it a little bit. I want you to understand the concept versus just type it in and get some random number that doesn't mean much. Think back to what we did at the start of the chapter where we introduced on day 1 what a factorial was. We did problems just like this. 6 factorial, if you take the greater factorial and start working your way down, you've got 6 times 5 times 4 times 3 times, now we made it to the other one, 2 factorial. And at this point, once you work your way down to the other factorial, now we can cancel the rest. And really, it's just 6 times 5 times 4 times 3. Which, if you type that in, what do we get? Yeah, 360 is what you should get. So that's kind of the formula version of things. Let me ask you again. I'm going to have you see it a different way so we're connecting how we've been talking about it to this formula. We said in this case we have the second number is like the number of blanks. Think about it this way. If this is blank number 1, how many options do I have for blank number 1? 6, right? I got 6 things that could go there. How many options for blank number 2? 5. How many options for blank number 3? How many options for blank number 4? Isn't that what we ended up with? 6 times 5, that's what this is. You start with 6 options, then 5, then 4, then 3. That's what we ended up with. That's what is happening in that formula. Okay? How about the second one here? 11 permutations of 3. That means we got 3 blanks and 11 things to go in there. You've got 11 times 10 times 9. Which, if I just show you the formula version to also confirm that, what you have, the top number is going to be the 11 factorial. The bottom number would be 8 factorial, the difference between the two. Okay, and that's just using that formula from the previous slide. And if you do it the longer way, you end up with 11 times 10 times 9, and now you get down. The 8 factorials cancel out. And there it is, same thing, 11 times 10 times 9. Okay? What do we get for that one? What is it? 990? Okay. Should get 990. Last one. This one you've done before. This one, not this exact problem, but you've done just stuff just like this. Oh, I forgot. Go to your calculator. Almost forgot to tell you. There's a button on the calculator for this, which I'm going to show you because next week we're going to use it. So if you go into the math button, go back to where the factorial is. Math, and then arrow over to probability menu. So if I hit the math button and then I go over to the probability menu, notice the second one is NPR. Tomorrow we're going to do NCR. There's the next one. There's your factorial. Now, depending on the calculator you have, some calculators, I believe the newer calculators, you can just go through and just choose number 2, and it should come up with like the little boxes that you can just plug in. Okay? Some older calculators, like the one that I'm using, what you need to do instead, let's say we did that first problem where it was 6p4. You need to type the first number in. So you would type in the 6 first. Then go to the permutations, go into math, and over to probability, and choose number 2. So you got to type in what n is first, then choose that, and then type in the r value, the 4. And if you notice, there's the 360 that we said. Okay? Or like the 11p3, you'd have to type in the 11, go and choose NPR, and then the 3. Okay? So just a heads up, you do have a button on the calculator, and how you type it in kind of depends on which calculator you're taking a look at. Like I said, as calculators have evolved, it's gotten nicer where you don't have to hit so many buttons. You just choose the button and put the numbers in, and it's much quicker. Yeah, you'll have a calculator on the test. When we get back to this,
A calculator or?
no, these. No, I was not trying to trick you on that. Yes, these calculators. Okay? On this one, if we take a look, last one, now I can't type this one into the calculator. But this is just like you did again back on day 1 of this chapter. If we use the formula for this, top number is n factorial. Bottom is the difference between the two. It would be n minus 3 factorial. And now this is the exact type of problem we started with in that very first assignment. Which one's the bigger factorial? Top. The top is the bigger factorial. N minus 3, you're taking 3 away. Which means, if we wrote this out, I would start with n. What's the next factor after n? N minus 1. You're always going one less. And then you would have n minus 2. And if you go one step further, then n minus 3 factorials from there will cancel each other out. And therefore, there's your final answer right there. And you do not need to multiply that out. You can just leave it as in factored form. Okay? But after that, like I said, the n minus 3 factorials will then cancel. Okay? Make some sense, hopefully? Like I said, the idea of permutations, arrangements, this is, it's pretty straightforward. I don't think the assignment will take you very, very long. This is kind of a setup to, like I said, combinations tomorrow. Similar idea, a little bit different. But then we're going to use combinations in number patterns and back to like algebra and stuff again next week. So here's what I have for you. The assignment, I've got a worksheet for you today. And let me hand the worksheet out and then I'll kind of explain a couple of things. I circled the problem numbers that you need to do today. I'm going to use the same assignment for tomorrow, the same worksheet. The ones that are circled are today's assignment, and then I put a box around the ones that are tomorrow's assignment. So you kind of know which ones to do which day, okay? Also, the answers are on the sheet. I'll show you that when we get there, okay?